Hello everyone and welcome to the first actual response that's not just an informational video. So, in today's video I will be talking about the first kind of round of things that Flatzoid has said in his stream, which will of course be linked in the description. And yeah, so I've managed to watch the whole thing through a second time and make some notes, so let's hear what Flatzoid is actually saying.
No, he's an astronomer. Yeah.
So he looks at stars and then he knows what.
One of the real scientists.
Don't worry. You're going to see everything that this guy presents as so-called trying to correct me, and unfortunately I'm going to have to correct him every step of the way. So...
Oh boy, it appears that Flatzoid was not happy with what I said. He apparently had to correct me every step of the way. Something, Flatzoid, did you want something else to say?
No, he's an astronomer.
Oh, sorry. Did you have something else to say there, Flatzoid? From Wikipedia. Entropy is a scientific concept.
Wrong.
Only a flat earther could just, without any counter evidence, just say wrong. I love it. So Flatzoid's verdicts in a nutshell are: my sources are wrong, I am projecting my ignorance, entropy is a process, and I'm wrong. So that's the takeaway messages for this term. Right now I will only be talking about the things about entropy, as you have maybe seen in the title. So let's have a look at my verdict. So my sources are wrong. Well, let's have a look. My sources are Wikipedia, as you've seen. Flatzoid complained when I showed the Wikipedia article that Wikipedia can literally be changed, and then he could go in there and change it as it is. That is in principle correct. However, the moderators, they don't just let anyone make corrections. Sure, if you correct it right now, it will stay like that for like a minute or two. But then the first moderator will come in and look and see that you changed it without references and without being an expert in your field, and is probably going to change it back. So really, whilst in principle it is a valid criticism, I mainly used Wikipedia because they express the basic ideas of a lot of scientific concepts very nicely. And I think the Wikipedia definition is a quantity was a pretty conclusive statement. Now, Flatzoid only criticized the Wikipedia one, not the other two, which is fun, because so do you accept those to be real? A Student's Guide to Entropy is a book published by the Cambridge University Press. That's an actual scientific book, right? That's a textbook. You can use this to study physics. So are you not okay with that? Apparently you aren't. But then again, later on you use my own definitions as what you see against me, which it's really not, but we're going to go to that. And the third thing I used is the Oxford English Dictionary under the physics section, which you also kind of didn't like. So here are the three citations again. You say that they are wrong. You even say that they contradict themselves, because I say that entropy is not a process, but it says right here that it can be used to quantify the irreversibility of a thermodynamic process, as if that makes entropy a process somehow, right? It clearly doesn't. I would like to make this clear, because I'm not entirely sure, Flatzoid, if you can properly read. And this is not supposed to be an insult. You have it right in front of you. Entropy is a central concept for many reasons, but a chief function in thermodynamics is to quantify the irreversibility of a thermodynamic process. It's like I say that velocity is there to quantify, it can be used to quantify a kinematic process, for example. Does that make velocity a process? No, it clearly doesn't. And from these statements, somehow I am lost as to why you would come to this conclusion. From these definitions, you conclude that I think thermodynamics isn't a process. Clearly it is. I don't know how you would reach this conclusion. Thermodynamics clearly is a process. And entropy can be used to describe said process, and entropy is a quantity. I don't think I can explain myself any clearer. Also, all of these three are valid. Feel free to present your own source with a definition of entropy, not thermodynamic process, entropy, and you know, we can see, but you ain't gonna find one. So that says that it's a process. So you know, so Flatzoid, what do you have to say to the definitions?
All it's proving here is if you get loads of different definitions, they all say different things.
Exactly.
Yeah. And you can mix them and match them how you want it to fit your agenda. You know what I mean?
Yep.
Now, I love how they seem to think that those
All it's proving
definitions
here,
somehow contradict themselves. They clearly don't. They're all talking about the same thing. If you think that these three definitions aren't roughly the same, I mean, they are more in layman's terms, right? That's the only issue with them. They aren't concise enough, so that you could get some kind of problem out of them, right? Because here it says entropy is a concept as well as a physical property, and here it says quantity. But that's not a contradiction. That's just not exactly the same thing. So all of these three definitions agree with themselves. I am at a loss of how you would think that they don't. And how stupid do you think I have to be to list three definitions that don't agree with each other? Feel free to provide your own one with a source, of course. So I think we got rid of the my sources are wrong. I will show a bit more later about another source. Let's another thing that Flatzoid has said a couple of times is that I am projecting my ignorance. I don't know, Flatzoid, what do you have to say that I am projecting my ignorance?
Anyway,
Yeah.
you just heard him, guys, talk about the process, correct? Saying it's wrong, while it says on his own definition that he agrees with, thermodynamic process. Let's just go back 2 seconds. Just listen to what he says.
Hear things like the process of entropy, or like entropy happens and things like that. And I want to make one thing extremely clear. Entropy is not a process.
Well, he's got a definition on screen. The quantum and the irreversible of a thermodynamic. Anyway, you just heard him,
I'm
guys.
so sorry.
The thermodynamic process.
Yeah. Thermodynamics happens in processes, but nowhere in my definitions does it say that entropy is a process. This is why I asked previously if you can read properly, because it doesn't seem like you can, to be quite real with you. Anyway, that's the first thing that I thought when I watched the stream until this point, is how would you reach this conclusion? It baffles me. It truly baffles me. I'm somewhat new to the whole flat Earth thing, right? Like not exactly new, but I was aware of it for a couple of years now. But I've only become interested in it like a bit over a year ago. A bit less than a year ago. And I've never heard, like, I never seen this amount of like not comprehending stuff. So. Of course, thermodynamic processes exist. Entropy is not a process, although more on that in a bit. Entropy is not thermodynamics. You know that, Flatzoid, right? Entropy and thermodynamics are two different things. Entropy is, for the most part, unless we're talking about the entropy in information theory or in some abstract parts of statistical mechanics or statistical physics, entropy is a part of thermodynamics. They are not the same. Entropy is very important in thermodynamics, certainly, but they are not the same. You know that, right? I just want to make sure. Do you have anything else to say about that, Flatzoid?
Not a good start, mate. Maybe you should understand the words you read on screen.
I agree. I very much agree, Flatzoid. Maybe that would be better for everyone involved if they actually understood the things that someone else writes down here. So I think we got away with projecting my ignorance. Maybe I am, but I think I know someone else who is very much projecting their ignorance. Anyway, let's now talk about the main part of this video, right? The entropy is a process and that I'm wrong. So entropy is a process. No, it's still not. And I'm wrong, which is always possible. But could you please show me where I'm wrong and provide sources for the things that you think I'm wrong about? So I'd like to give a bit of a better definition of entropy. Don't be scared now. We don't need any of the upper part here. This definition comes straight from the go-to textbook when teaching thermodynamics. We used it in our university to learn thermodynamics. It's by Herbert B. Kalin, and it's called Thermodynamics and an Introduction to Thermostatics, the second edition. I only found the cover for the second edition online. We used the fourth edition, I believe. And in there, entropy, the existence of such, is a postulate, in this case postulate 2. There exists a function called the entropy S of the extensive parameters of any composite system, defined for all equilibrium states and having the following property. The values assumed by the extensive parameters in the absence of an internal constraint are those that maximize the entropy over the manifold of constrained equilibrium states. What does that mean? So I understand that for a layman this term is completely useless, but I've made my best try to explain to you what that actually means. So first, the entropy S of a system is a function of extensive parameters. Now what does that mean? Now function is here meant, of course, in a mathematical sense. So as y is a function of x, f of x, you've probably heard that. So is S a function of U, which is the internal energy, or the heat, it's sometimes called, or sometimes heat energy. V is the volume, and N is the number of particles. If you have multiple particles, it's a function of the number of the particle of the type 1, of type 2, and so on until you have gone through all of your types of particles. Extensive parameters are, by the way, parameters that scale with the system. So they are not relative to the amount of particles, like for example intensive parameters would be the intensive U, so the intensive heat would be the normal extensive heat divided by the number of particles. Of course, again, if you have different particles, now here it gets a bit tricky because you can have different intensive parameters than if you have multiple particles, but that's not important right now. So essentially what this sentence means that Kalin provides here is that if you know the heat, the volume, and the number of particles for a thermodynamically easy system, sometimes there are also chemical factors in place. If you know these three, you can calculate the entropy, because entropy is a quantity, thus you can calculate for it, by the way. I will explain more about that later. The tricky part here usually is the heat, or like the heat energy. That's the tricky one. The volume is most of the time rather easy, and the number of particles is also not too difficult. The heat energy is where the crux of the matter is. So I thought I would give you a brief calculation for the ideal gas. Now, Flatzoid, I know that you consider yourself to be an expert on the ideal gas, so please feel free to show a better calculation. But in principle, I won't bore you with the maths in detail. In principle, you start out with the ideal gas and you form it. You change the algebraically. You rearrange for U. Sorry, I couldn't think of the word right now. You rearrange for U, and then you do a whole bunch of equations, the Gibbs-Sturm equation, the Euler equation. You put those together, you integrate and the such, and you end up with an expression for entropy. This is entropy. Mu here, by the way, mu is the chemical potential, I believe it's called, what I talked about earlier. So this is the entropy for an ideal monotypic, so with only one type of gas in it, like only hydrogen or only oxygen. This is the entropy for the ideal gas, depending on all of these parameters. C is a constant, by the way. So, and I would like to make this very clear, entropy is a quantity. You can calculate it and you get a value out of it. The unit for entropy is joule per Kelvin. Entropy clearly is a quantity, and it's not just me saying that. I got that straight out of Kalin's book, by the way. He does the same calculation. So, please, Flatzer, please, if you could show me where I'm wrong. Or is Kalen wrong, the professor of thermodynamics? I'm curious about what you think about that. Also, a brief explanation about units, because you seem to get that one extremely wrong. Extremely wrong. Is that 1 meter, for example, right here, is length. So you can quantify the distance or the length to things, right? So clearly, it's a quantity, it's not a process. Here I have velocity. That's my attempt at drawing a bicycle. I do apologize. Let's say the bicycle is going 5 meters per second, right? Then that's a velocity, and it's used to quantify how fast stuff is going. It's a quantity. Velocity is a quantity, not a process. Velocity can be used to describe a process, but it itself is not a process. And a bit more complicated, that's my attempt at drawing a piston, from an engine, but also, again, I do apologize. Power, like wattage, kilowatts that we have here, is power. And power can be used to quantify, or like watts in this case, are used to quantify power. How much energy per second something can use or can create, in the sense of transform it from some other sort of energy into, in the case of a motor, kinetic energy, right? It's a quantity, not a process. So things that have units are quantities and are not processes. Entropy has a unit, joule per Kelvin. That means that entropy is not a process. I can not express myself more simple than that. It's really not difficult, Flatzoid. It's really not difficult. So, and at the end here, I thought I would give the big explainer, the big brain in the field of thermodynamics. Some 3 very easy exercises. Here is problem 1. I will quickly read you through it. We got that in the first week when we started our thermodynamics course, so it's really easy, really basic. The second one here is which one of the 2 statements, these 2, violates thermodynamic principles, if any. Could be none. Especially regarding entropy, because what this S is here? This S here is entropy. Well, would you believe it or not? This is taken from the Kalen book, by the way. And the problem 3, my favorite exercise here. By the way, we got that one in the second week of the thermodynamics course. And we got that one in the third week, which is which of the 3 equations... find the 3 equations of state in the entropy representation for a system with the fundamental equation. Here is the fundamental equation. And do you see this S here, the small s? That's the intensive entropy. So I doubt that you know what an equation of state even is, but you can teach me better. You can let me see that I'm wrong here. I would urge you to do all of these 3 problems to show me that I'm stupid. If not, I will publish the result videos of how I would solve them in like a month or so, I guess. And with that, I thank you very much for watching. This has been by far the most work that I've put into a video, with all of the cutting, with all of the preparation, with all of the selection of what I would put into this video, because there's so much material. I will do a couple of more videos about the talk, and I will also do at least 1, maybe 2 videos only about things that Flatzoid has said that weren't even on topic, just side comments that he gave that were so scientifically wrong that I have to talk about them. It's like a whale fall. If you know, when a whale dies and the carcass drops to the ocean floor, the whole ocean floor kind of comes together and feeds on the whale fall. And that's kind of what we are doing with what I want to do with Flatzoid's videos, because there's so much so much that you can make videos about in this 2-hour stream. It is truly amazing. And with that, Flatzoid, do you have any closing remarks for this whole ordeal?
The problem is indoctrination.
Yep.
That's it.
You have
crazy.
a belief that you...
I couldn't agree more. And with that, I thank you very much for watching. If you did enjoy it, consider leaving a like. If you enjoyed it a lot, consider leaving maybe a sub with me. That would be highly appreciated. And I will see you in the next video that I am very much looking forward to. I'm also very much looking forward to Flatzoids' response to this one. So with that, have a good one, folks, and I will see you in the next one.